Hi everybody. This is the second part of the video of how to create, copy and delete elements with Revit API. If you haven't seen part 1, link will be somewhere there on the top and you better watch it first because I explain a lot about Revit API documentation and show you how to create different elements. Now let's just jump back and continue creating our elements. Last time when I left we finished the function for family instance and we placed a few instances right here in Revit. So the next thing we're gonna talk about is sheets. Let's create some sheet. I'm gonna bring the Revit API. And same as before, we're gonna look for view sheet class. Then we're gonna open it. I'm gonna zoom a little, go to methods, and right here I can see the create method. Click on it. There's just one method, and it's very simple. We just need to provide a document, and also we need to provide title block type ID. I'm gonna copy this, go back to PyCharm, arguments, and then I'm gonna paste it here. So new sheet equals view sheet create, and then we provide doc and title block. Now we need to get this title block ID. I'm gonna make a variable right here. For now it's gonna be empty. Let's remove this. So to get title block ID, we're gonna use the filtered element collector, same as we did with some of the previous elements. I'm gonna write filtered element collector, give it a doc of category. I'm gonna use built-in category of title blocks. Then we need to say where element is not element type. And lastly, I need first element ID. Now let's break it down somewhere here. And also let's update the name and the sheet number of this new sheet that we are creating. I'm just gonna write new sheet. Then there is a property called sheet number. And in here we need some random sheet number. And this has to be a unique value. Otherwise you're gonna get a warning saying that the sheet with this sheet number is already existing and it will not rename it and give you some warning. And to update the name, I'm just gonna write new sheet.name. And I'm gonna write here random name. Okay, let's go to Revit in EF Tutor tab, click on this button, and I can see right away that there is the plus sign appeared right here, and then there is our sheet, random sheet number, random name. So this is how we create our sheets. So let's add a few comments, and we can comment out this whole block. And the next one is views. I'm just gonna create a 3D view, but all the other views like floor plan and section should be similar. Let's open up Revit API docs, and in here write view, and notice that it's gonna give you the view class. And if you're gonna look, this class doesn't have any create methods, because view is just a general class from where many properties and methods are inherited by other views. You actually need to look for specific views such as view section, view plan, and so on. In my case, I'm gonna look for view 3D class. And now if I'm gonna look in these methods, somewhere here there should be a create method. In case of a 3D view, we can create isometric or we can also create a perspective view. I'm gonna go with isometric. And this one also looks very simple. We just need to provide a document and then we provide view family type ID. Let's go back to PyCharm. I'm gonna write arguments and then place this here. So let's create a variable called new 3D. Then we're gonna take the class of the 3D view, which is view 3D. And in there is a create isometric. As you can see, we need to provide a document and we need to provide view 3D type. First of all, I wanna get all the view types. All view types equals filtered element collector of document of class view family type. This is what we're looking for. And then I'm going to convert it to a list of elements. Now inside of it there are view types for floor plan, section, elevation, and we need to find the one that has the 3D in it. So in here I'm just gonna make a list comprehension. I'm gonna write view type for view type in all view types. If view type view family equals view family. And then here's all the selection that we have. We can get all elevations, we can get all floor plans. In my case, I want to get all 3-dimensional. And now we just need to choose a random one. I'm just gonna take the first one. I'm gonna write create 3D view. And now I can go to Revit and have a look. At the moment I have just two views. I have a floor plan and just a regular 3D view. Now if I'm gonna go to EF Tutor, click on this button, it's gonna give me a warning saying expected element ID and got view family type. So we're gonna come back here and we're gonna change it to ID. Go back to Revit again, click on it, and I can see I made a new 3D view. I can click it again, and I'm gonna make another view, and so on. And you can create all the different view types the same way. You just need to get the different view type. So now let's comment all of this out. And the next element we're gonna create is filled region. Let's open Revit API. Then in here, I'm gonna write filled region. Then in the filled region class, as usual, we go to methods, and then there's our create method. So to create a filled region, we need to provide a document, then we need to provide type ID of a filled region, then we need a view where we want to create it, because it's a view dependent element. And lastly, we need to provide boundaries. And boundaries have to be a list of curve loops. We can click on it, and it says here that it's a class that represents a chain of curves. Let's go back. I'm gonna copy this as usual, and I'm gonna bring it over here. Now, create filled region. we're gonna write region equals field region create. And now I can start filling all the arguments. First one is the document, then we need region type ID, then we need view ID. I'm gonna use the active view. And lastly, we need to make boundaries. We don't need this anymore. We have to find region type ID, and we also need to find boundaries. To get the region type ID, we can use filtered element collector as usually, or we can also go to Revit API docs. And right here I want get default element type ID. Click on that one. So this method comes from document class, and then we can provide element type group, and it's going to return us a default type. And if I'm going to open this element type group, you can see that right here there are all different members that we can use. We can get the floor type, roof type, and so on. So I'm going to copy this. I'm just going to paste it like this. So this method comes from document, and this element type group, if we put a dot, it will offer us lots of different options. And here on the top I can see field region type. Now the next thing, we need to actually build a curve of our field region. I'm going to build 4 points. Then I'm going to connect all these points and create lines. And then I'm going to take all these lines and put it in the curve loop. So let's start creating our points. I'm going to make point 0 equals XYZ. I'm going to write 50, 0, 0. Then I'm going to duplicate it a few more times. This is going to be 0.1, 0.2, 0.3. And now I need to give all the values. So here it's going to be 55. This one is going to be 55 and 5. And this one is going to be 50 and then 5. Now we need to convert it all in lines. So I'm going to write lines. First one is line 0. We're going to take 0.0 and 0.1. Then duplicate it a few more times. Make it 1, 2, and 3. And now I just need to always take the next point. So here it's going to be 0.1, 0.2, then 0.2, 0.3. And lastly, we're going to take 0.3 and then 0.0 because we need to return in the same position where we started. So in the next step, we need to create curve loop. As we can see right here, if we're going to select it, you can see that it has a constructor and it's just going to construct a new empty curve loop. So let's create it. I'm going to call it boundary equals curve loop. Let's make a comment boundary. And if you go to methods, you can see that there is a append method to append the curve to this loop. Let's go back to PyCharm, and I'm just going to write boundary, append, line 0, line 1, line 2, line 3. And lastly, we need to create a list that contains all the different boundaries, because we can create a field region that has the outer boundary, inner boundary, and so on. And as we saw in Revit API docs, we need to provide a list of curve loops. So let's create it. I'm going to write list of boundaries. Then create a variable list boundaries, then it has to be .NET list. It only takes the curve loop elements, and let's make it empty. I'm gonna remove this because I don't need it anymore. And by using add method, we're gonna add the boundary that we have just created. And I'm gonna provide it here as an argument. I think that should be enough. So we got our region type, we created points, then from these points we created lines, then we turned it into a single boundary, and then we created a list of boundaries and appended it there. Let's open Revit and have a look. I'm gonna click on it. And you can see right here, our field region has appeared. You can move it, click on it again, and create another one. And this is how we create a field region. Let's come here, and we can comment all of this out. So the next one is floor. Floor is pretty much the same, but now as the 3D element. We'll also need to create a few points, lines, then we probably need to create some sort of boundary. Let's open Revit API docs and actually have a look. What do we need? I'm gonna look for floor class. And in methods, there is no create method anywhere. It means that we have to look in the document class, open it up, go to methods, and then in here I can see there is a new floor method. Click on it. But before gonna look at any of the methods, I want you to pay attention right here on the top, where you can see the Revit numbers. If I'm gonna scroll through, you can see that in 2019 it was updated, then in 2020 it didn't change. This one is green because this is the version that I'm using. But starting in 2022 it has updated, and in 2023 this class is missing, which means that if you're gonna create a tool that creates floors, it might work in version 2019, 20, 21, it might work in 2022 depending on the changes, but it will not work in 2023 because in there were some changes. So back to floors. In here we need to choose one of the methods. So I'm gonna go with the second method, because in here I can choose on which level I wanna place my floors. And these are all the arguments that we need. Copy it into PyCharm as usually, and I'm gonna write new floor equals document create new floor. And then we're gonna write all the arguments as usual. So it's gonna be profile, floor type, level I'm just gonna write active level, and then false for structural boolean. I'm gonna remove this. Now we need to create a profile, which is gonna be a list probably. And we need to find some floor type. So for floor type, I think we can use this method right here to get default element type. Let's try it. I'm just gonna paste it here, then replace this. And in here, we just need to look for floor type. This should be good. And let's have a look in Revit API what kind of profile we need to create. In this case, it's a curve array, and you already know how to work with a curve array. The thing is that here, that if you have a floor with an opening, you cannot provide it in a single curve array. Because in the case of filled regions, we had a list of curve arrays, so we can provide the outer boundary and inner boundary. In floors, this is not possible until Revit 2023. So I'm gonna click on it and look floor, and now it has appeared in the version 2023. And here on the top it says that it's missing in 21, 20, 19 and all the previous versions. It's also available in 2022. And in this case, it is possible to provide a list of curve loops. So I'm gonna go back. To make it easier, I'm just gonna copy this part from regions. So we're gonna create some points, some lines, and then here we're gonna create a curve loop. Paste it here, then we can uncomment it. And we also want to move it a little bit to the right. So it's everything is gonna be 60. Then lines is the same, and then boundary is the same. And I think we can use this boundary inside of here. I think that should be enough to create a floor. Let's go to Revit and test it. Click on this button, and it tells me that it expected a curve array and it got a curve loop. So there is some difference. Let's come back in here. And in here where we created a curve loop, we need to create curve array. I hope that curve array also uses the append method, but we're gonna find it out very soon. Click on it. Now it tells me that it expected floor type and I gave it element ID. I'm gonna come back. So if this is ID, I can easily get the floor type by using the doc get element method. So now we're getting the floor type. Hope there are not gonna be any more errors. Click on it. And now here we go. This is our floor that we have just created with Revit API. And I believe this was the last element for today. Now I just want to show you how to copy your elements in the project and how to delete your elements. We're gonna comment all of this out. And for copying elements, I think that would be easier if I would just take this floor and copy a few instances to the top. I can also make a few more floors, so there's more than one element that we are copying. So ideally, I want to take these 3 floors and copy it all the way up. So let's change the type to something else, because white is not very visible. Now it's better. So the first step is to get all the elements that you want to copy. And we're gonna get all floors in view. For this, we're gonna use filtered element collector, provide doc, and give it the active view ID. Then of category, built-in category floors, where element is not element type. And then 2 element IDs, because we need to provide element IDs to copy your elements. Let's go in Revit API and actually find this class and see how to copy elements. I'm gonna write copy elements. I can see right here some method. This is gonna copy the set of elements from source document to destination document. So this method is valid if you wanna copy different elements between different projects. In my case, I'm gonna go one up. And I think I need to use this one because I wanna copy elements and place at a location indicated by given translation. By translation, it means a vector, so I need to create a vector where to move it. Notice that this is coming from element transform utils class. So I'm gonna open it. First, I'm gonna paste the name of the class from where it's coming. And then we're gonna use copy elements. So now we can look at all the arguments that we need. We can copy this. It tells that we need a document, we need elements to copy, and it has to be a list of element IDs. And then we need to create a translation, which is a vector. And to create vector in Revit API, we'll also use the XYZ class. I'm gonna go to my PyCharm, make here a temporary variable. Now I'm gonna fill the arguments. So the first one is doc, then elements to copy, and then vector. So elements to copy, it's easy to create. We just need to create a list of element IDs. I'm gonna provide this list of floors in active view. And for vector, we just can say that we wanna take everything and move everything 10 points up. So I'm gonna X is 0, Y is 10, and Z is 0 as well. To make it a little more interesting, let's make a loop. For I in range of 1 to 6, I'm gonna modify my vector for each iteration. So I'm gonna multiply it with a Y, then it's gonna get 10, 20, 30, and so on. And then the next step, I'm gonna copy these elements. Now go to Revit, click on it, and I can see that it has created this array of floors. So this is how you copy elements, this is not so hard. And lastly, how do we delete our elements in Revit API? Well, first of all, let's copy this part right here, because we also need to use the element IDs of our elements. So I'm gonna get all floors in view. I'm gonna create a list of elements to delete. Now I can open Revit API, right in here delete, and I can see there is a delete and then delete elements. I'm gonna click on that one. And in here it says that delete a set of elements from the document, and it comes from document class. All we need to do is provide this list of element IDs, same for the copying, but we don't need anything else. No vectors, nothing. Let's write here delete elements, then write doc delete and elements to delete. Lastly, go to Revit, click on it, and all the floors are gone. And this is how we delete our elements. I hope this gives you a very good overview of how to create, copy, and delete your elements using Revit API. As you saw, we have to work closely with Revit API documentation to always find the right method. Leave a like if you found value in this video so it can reach even more people. And I want to thank all my active supporters on Ko-fi and Patreon pages. And as always, I'm gonna see you in the next video. Happy coding!